Hey, what's up YouTube? Welcome to another Moralis blueprint. Mobile applications seems to be the future for Web3, and no one seems to be building dapps on mobile. So this is your opportunity. This week, you are going to learn how to create your own wallet from scratch using Flutter, integrating Web3 into your mobile development. At the end, we are going to have something like this. We are going to be able to create a new wallet from scratch, which is going to generate a mnemonic phrase, and using this mnemonic phrase, we are going to be able to verify it and generate a new private and public keys. With that, we are going to have access to a new wallet address, on which we are going to get its balance. Of course, as this is a new wallet, it's going to start at 0. But for example, if we import a new wallet from an already created mnemonic seed, we are going to have direct access to its balance, the NFT collections on this wallet. We are going to have also the ability to send funds to another wallet. And of course, if we want to start from scratch, we can always log out and create a new wallet. So if you want to learn how to accomplish this, keep watching because we are just getting started. What's up YouTube, my name is Vasily, your Web3 instructor from Latin America, Ecuador. I've been building on the space since 2020 with cool crypto projects. In my free time, I really enjoy singing and playing the guitar, and if the time is good, I like to go out and take some meditations. But enough about me, let's go back to the video and start building. So first thing first, let's address the elephant on the room. And yes, mobile development for Web3 is not that good. We have the official frameworks for mobile development, such as Swift and Kotlin for iOS and Android respectively, and then we have the hybrid ones, such as React Native and Flutter. And the problem is that as these are not the most popular frameworks for development, and Web3 isn't yet integrated that well into mobile applications, take in mind that some of the libraries we are going to use today may get deprecated really fast, and also we might have to do some tinkering here and there. Besides that, I think that this is going to be a really good blueprint on which you are going to understand how you can integrate Web3 technologies into your mobile development workflow, and also connect it to the Moralis APIs, because yes, they are the fastest on the Web3 space. So let's stop wasting time and start coding. So let's get started. First of all, let's create a new project over here. So let's say Flutter create Web3 wallet. This is going to create an empty project. After the process finishes, we are going to have the default Flutter application. As you can see here, is the simple application to add one to a number, and this is going to keep updating this. So let's transform this into the Web3 wallet. For that, first, we need to talk about the libraries we are going to use to build this. The first and the core of those is the Web3 Dart. It's a way to connect to a Ethereum node and send transactions, interact with smart contracts, and much more. The latest version at the publication day of this video is 2.6.1. Also, we are going to use the BIP39 package. This is a Dart implementation for Bitcoin BIP39. This is the way on which we are going to generate the mnemonic phrases to create our wallets. Please, if you want to understand deeply how this works, don't forget to check out the documentation, including the abstract and the motivation to create this standard. Also, we are going to use the ED25519 key. This is a way just for sign with public keys. And finally, the hex library, which is going to be a way to easy encode and decode hexadecimal characters, such as the wallet address. So we need to add all those packages on this pubspec.yaml. Let's go under dependencies, and under Cupertino icons, let's add them all. Also, we are going to use the provider package. If we save this, this is going to automatically run the Flutter pub-get, which is going to add and install these libraries to our project. So first thing first, I'm going to get for granted that you already know how to manage Flutter, at least on the basic level. Remember, all the Flutter structure is based on widgets. So now I'm going to just transform this interface into a simple button on which we are going to be able to create that mnemonic phrase. So we are going to start like this, and the final result is going to be this. As you can see here, I replace everything with just a scaffold with an app bar with the title crypto wallet. And here we have an elevated button, which for now doesn't do anything. So let's add the functionality to, as I told you, create that mnemonic phrase, the private and public keys. So for that, I'm going to create a new file over here on the lib folder called walletprovider.dart. Let's import the libraries we are going to use. So first of all, Web3 Dart, then the BIP39 as BIP39, the 825519, and the hexadecimal package. Now let's create an abstract class wallet address service. This is going to have the string function generate mnemonic, a future function called get private key, and a future function called get public key. These abstract classes works the same as interfaces on Solidity contract. So let's create that main class wallet provider extends change notifier. This is going to implement that wallet address service. And of course, this is going to be mad at us because we need to implement those functions. Otherwise, we should keep this as abstract. Also, this change notifier is just a way of Flutter to announce some variable or state changes around the application. And for that, we are going to also need the Flutter Foundation package, which I'm going to paste over here. Now let's create the functionality for those. We're going to go through this process in order. First, let's use the functionalities to create the mnemonic phrase. So as this is an abstract, we need to override, let's say string generate mnemonic, and this is going to just return a BIP39.generate mnemonic. Again, if you don't know which functions this library has, well, we can always click on the function name and check all the functionality on the code, or on the other hand, you can just always check the documentation on the Flutter package. And also, as you can see here, you're going to have something called AP reference, on which you can go and also read more documentation about how this works. But yes, as simple as that, with a simple function execution, we already have a way to generate that mnemonic phrase. You know, those long sentences with random words, which are going to be used to create our private and public keys for our wallet. Now let's implement the second function, override. This is a future string get private key. This is going to receive the mnemonic phrase we are just generating as parameter. This is going to be an ISIC functionality because again we are using future, and here we are going to generate that. And also, as you can see here, the GitHub Copilot is already generating everything for me, but let's explain one by one. First of all, let's generate a seed. So BIP39 to mnemonic to seed, and use the mnemonic we are going to send as parameter. So remember, the seed is like a pattern that this is going to use in order to generate that public and private keys. Again, if you don't know how this works, please check out the BIP39 documentation and its basis. Now we need to create the master key. So final master is going to be equal to await ed 25519 hd key dot get master key from seed, and we are going to use the seed we just generated. This is the master seed we are going to use to create our wallet. Then we need to say final private key. This is going to create that private key for the first account on that wallet. Hex dot encode master key. And finally, let's return that private key. With that, we already generated a mnemonic phrase. We are going to generate first this, use that to generate a seed based on that mnemonic phrase. Using that seed, we are going to use this ed255 library to generate a master phrase. And with that master phrase, we are going to encode our private key. Finally, let's create the functionality to have the public key, which is going to be shown on our wallet and the one we are going to share with others. So again, override. This is again a future function. This is going to return a Ethereum address. The Ethereum address came from the web3.dart. Let's say get public key. And again, if you are doing this with me right now and you have GitHub Copilot, just let the auto completion to work for you and just listen to the explanations. So let's say string private key. We are going to send the private key because, as you know, with the private key, we generate the public key. The public key is going to be, again, the one which is available worldwide. And related to that public key, which is the one we are going to share, we are going to use the private key we just generated to sign the transaction. So let's say async, because again, it's going to be an async function. Let's say final. The private key is going to be equal to it private key dot from hex, and we are going to send over the private key we are sending here as parameter. Now we can generate the wallet address. So final address is going to be equal to await private dot address, and finally let's return that address. And as this is that, we have all we need to generate a wallet from scratch: the mnemonic phrase, the private key, and the public key, which is going to be the wallet address. Now let's test this out. This is called wallet provider.dart. So let's return to the main function, and let's say here import wallet provider.dart. We can do it like this, or we can do it as a package. But as we want to test this out quickly, let's do it like this. Also remember, as we used this change notifier on the wallet provider, just as a good practice, I'm going to replace this run app to have this change notifier package sending over the context for the wallet provider. So here, just after we generate or build this widget, let's declare a new instance of the wallet provider. So final wallet provider equals to provider.of wallet provider. And we are going to send the context as parameter as usual on Flutter application. Once we have the instance of the wallet provider, we can use that into the onPress functionality on the elevated button. So we can say final mnemonic phrase is going to be equal to the wallet provider dot generate mnemonic. Again, we are just calling the functions we just created here. So let's create the mnemonic. Let's create the private key. The private key is going to use the mnemonic we just generated. And let's generate the public key, which again is going to use the private key we just generated. With that, let's add some print statements. Remember that print statements on Flutter are just for testing. We shouldn't include any print statement on the final builds. So I'm going to print the mnemonic, the private key, and the public key. Let's save this, reload the application, and now if we open the terminal, let's go here, new terminal, on the debug console, if we click on generate wallet, as you can see here, let me make this bigger. If you see, we generate all of those: the mnemonic, the private key, and the public key. So these are just random strings we just generated, but actually, no. This is an actual wallet address we just created using this function. How can we know? Well, let's just take the public key, copy this, go to our browser, open etherscan, paste that wallet address here, and as you can see here, this is an actual wallet. So, as this is that, we just generated a wallet. We have the mnemonic phrase we are going to be able to use to import this wallet, let's say on MetaMask or any other wallet, the private key for the first account, and the public key. Of course, we are not just going to create this and then import it into MetaMask. We are going to create our own wallet 100% on Flutter. But I just wanted you to know how easy this process was. We just created a new wallet from scratch with what? Just 3 simple functions and importing some libraries. But let's keep building. Now, as we know, we can create a wallet really easy. The first step for us is to create the interface and the actual functionalities for it. However, we have some problem here, and it's that if we generate these private keys and we don't store them inside the application, well, each time we close and open again the application, it's going to erase those variables. So we need a way to store those inside of the application memory. So before we continue, let's modify the wallet provider. And as you can see here, I have some different tabs for different pages. Don't worry about them right now. I'm going to explain them step by step. So on the wallet provider, let's modify and add some functionality. There is a package called shared preference plugin, which is going to allow us to do exactly that, store simple data inside the application memory, so we don't have to relay into an external database, because this is going to store permanently some information inside the app really easy. So first thing first, let's go to the postspec.yaml, add that shared preferences, and now on the wallet provider, let's import that. Now let's create a variable to store that private key. So let's say here, variable for private key. This is going to be a string private key. Now we need a function to load that private key. So on the wallet provider class, let's create that variable to store private key. So string private key. Let's create now a function to load that private key. So it's going to be a future void function called load private key, and it's going to use these shared preferences. It's going to be called prefs. It's going to be equal to await shared preference dot get instance, and this is going to set up that private key. The private key is going to be equal to the prefs dot get string private key. Now we need another function to store that private key. So future void set private key, which is going to receive the string of the private key. It's going to be again an async functionality. And inside of this, we are going to set shared preference equals to prefs.await shared preference get instance. Again, we are going to get the instance. Then we are going to set the string. So await prefs.set string, the private key, as the private key. It means this variable. And of course, we are going to notify the listeners. And this is it. As easy as that, we now have a way to store this private key inside the application, no matter if we close it over and over again. So with that said, we are ready to start building the whole functionality for the wallet. From this part on, I'm not going to explain the actual building of the interface of the application, because it's going to take a lot of time and it's just to put some widgets here and there. But instead, I'm going to stop to explain the important parts regarding on how to connect Web3 technologies on these widgets. But don't worry, remember on the description you are going to have two links, one for the final project and another for the template, on which we are going to start as this to this. This is the template you are going to download on the link on the description, which has the already interface we are going to use for this project, but without any type of functionality. So for example, we have the two options: to create a new wallet or to import from seed. So let's get started with the create wallet functionality. Also, as you can see here, it says please store this mnemonic phrase safely. And here we have a text just stating mnemonic phrase. We should replace this with the actual mnemonic phrase. So let's do that. This is going to be a really simple process because we already have our wallet provider on which we have the ability to create that mnemonic phrase. So here we are on the widget called generate mnemonic phrase.dart, and let's get started. Here on side of the widget, let's declare some variables. So first, let's say final wallet provider. It's going to be equal to the provider dot of wallet provider, and send over the context as always in any Flutter application. Once we have the wallet provider, we can say final mnemonic is going to be equal to wallet provider dot generate mnemonic. And now, as you might already know, the mnemonic phrase is going to be a really long sentence with random words. So now I want to split them up. So I'm going to say final mnemonic words is going to be equal to the mnemonic dot split, and split based on the spaces on that phrase. I'm just going to replace this because it's mnemonic. It was misspelled, and this is it. With this, we are generating that phrase. Now we just have to render that over here. So instead of having here on the children of this widget this text, let's erase the text and create here a list. So list dot generate, the length of this list is going to be of that mnemonic words variable. So mnemonic words dot length. Here we're going to send over a function. So let's say a index and this is going to render a padding. And inside of this padding, we are going to say first the alignment, which is going to be vertical, and this is going to have a child, which is going to be the text and a enumeration. So the index plus 1 and the mnemonic words index. If we save this, as you can see here, this is going to update this, and we are going to get the mnemonic phrase with all the words one by one. Now we need to copy this to the clipboard. Again, the reason is because once we generate this mnemonic phrase, it's not going to be stored on the application or also anywhere, and the user is responsible to copy it to the clipboard and then paste it into a Notes application or keep it safely in another app. So here we have this elevated button, copy on the clipboard, and as you can see here, the button doesn't do anything right now. So here we need to add a function. This function is going to be called copy to clipboard. So let's create that function. Here I'm going to say void copy to clipboard. This is going to use the clipboard widget. So clipboard dot set data. The clipboard data is going to have a text. The text is going to be that mnemonic phrase. Then we are going to have a scaffold messenger. This is just for having a notification stating that we have copied that. So scaffold messenger of the context. And we are going to say that we have copied that to the clipboard. So instead of the auto completion, I'm going to say mnemonic copied to clipboard. And also, as we want to verify this afterwards, I'm going to automatically push the next page. So navigator.push, and this is going to send over, as always, the context. The material page root is going to have a builder, and this builder is going to render the verify mnemonic page, on which we are going to have another widget which is going to be used to verify this mnemonic phrase. So I'm going to save this and let's test this out. So let's click on copy to clipboard. As you can see here, we have this announcement that the mnemonic was copied to the clipboard, and we can just take it and paste it over here. Again, we have another widget over here, which is going to be used to verify this, called verify mnemonic. If we click here, we are going to be able to add functionality to this. So let's do that. So as you can see here, we have a Boolean variable called isVerified, which is going to default to false, and a string, which is going to be the verification text. So let's add that functionality. Let's say void verify mnemonic. This is going to have a wallet provider, as we did before, and we are going to verify that the string we are setting up here as input is the same as the one generated by the wallet provider. So I'm going to say that if verification.trim is equal to the widget.mnemonic trim, then we can create the private key, because remember, we use this mnemonic phrase to generate that private key. So I'm going to say again, wallet provider dot get private key, and we are going to send the widget dot mnemonic, and then after we do this, we are going to set up that private key. This private key, as you can remember, is the variable we are going to use, and after that I'm going to say then. Here I'm going to put a function on which we are going to pass the private key, and inside of this function I'm going to update the state from is verified to true. So let's say set state and is verified equals to true. Also, I already left you this navigate to wallet page, which is going to be used to navigate to the wallet page. So here on this verify button, I'm going to use that new created function, verify mnemonic. Let's save this. Let's click on verify. This is going to verify. And as you can see here, this next button changed from inactive to active because we have the elevated button over here. And this is going to verify if the is verified variable is true. If it's true, the next button is going to be available, and this next button is going to execute that functionality navigate to wallet page. So let's click on next, and this is going to lead us to the actual wallet page. On the wallet page, we are going to have an interface like this, in which we have the wallet address. For now, is a burned text, the balance, which of course is 0 because again this number is burned, and some more interface. For example, we have a tab on which we are going to add the NFTs and the options on which we are going to add the capabilities to log out. So let's get started by setting up here the wallet address. However, there is something important to consider also here, and is that, remember, we have on the wallet provider this shared preference library on which we have the load private key, which is going to load that variable into the application memory. We have also to do that over here in order for that to be persistent. So if we close the application, then the private key will persist on time. So let's do that. Let's go to the wallet. Let's create some variables over here just after the class initiation. So let's say string wallet address, string balance, and string PB key. This PB key is going to reference that private key, and it's just because we don't want to keep loading this over and over again, but instead just load the private key here on the wallet page, and if we navigate, for example, to the send page, send that private key over as a variable instead of keep loading it from the shared preference. So let's create a new function here, which is going to be a future void load wallet data. This is going to be used to load all the information of the wallet. Of course, it's going to be an asynchronous function. Let's create a new instance of the shared preference. So shared preference await get instance. Then we are going to declare that private key based on the preference, and of course it's going to have this question mark just to verify if the private key exists or not. So we are going to do something. If we don't have a private key, or if the private key is null, we are going to say that first we are going to declare the wallet provider, and using that wallet provider, we are going to load that wallet provider.load private key. And again, remember, this function is going to store the private key value inside of the shared preference. Now let's create a new Ethereum address using the web3.dart, and it's going to be equal to the wallet provider dot get public key and sending over the private key, which is coming from the shared preference. Now we can use a set state to update the widget. So set state, and here we are going to say the wallet address is going to be equal to the address.hex actually, and also that the PB key is going to be equal to the private key. Now, each time we load this widget on the init state, we are going to execute this function, so load wallet data, and now we can show this app here on the wallet address widget. So instead of saying here 0x, let's erase this and put here wallet address. Let's save, and this is going to be blank for now. And the reason is the following. Here on the wallet provider, we created this set private key functionality, right? But here on the get private key, when we use that mnemonic phrase to generate that, we are not using this set private key. So it's as easy as use that functionality over here. So I'm going to say await set private key to the private key we just generated using this mnemonic phrase. Let's save this. And now we can go again through the process of creating the wallet. So create wallet, copy to clipboard, paste it over here. Remember, the user must paste this outside the application to keep it secure. Let's click on verify, next. And as you can see here, boom, magic. We have the actual wallet address shown up on here. Now, there is something interesting over here. Let's now restart the application again. So let's click on restart. And instead of restarting to the main page, it means to the create or import seed is just restarting to the wallet address. And the reason is because now we have this persistent private key on the application. Because on the login page, this is going to verify if that private key exists. As it does, it's going to directly return the wallet page using that private key, of course. And if not, it's going to send over that create or import page. So let's add the logout functionality. It means erase the stored private key in the application. So I'm going to put that log out here on the options. So I have to go to the wallet, and here on this center view, which corresponds to the options, is the place I'm going to set over that. And you might be wondering why you have these enormous blue lines here. And the reason is because this is going to expect me to use keywords like const for some of the variables, but this is for now because we didn't add functionality to these tabs. Once we add them, these blue lines are going to disappear. So here on the center side, let's add that log out functionality. So let's set here a child. This child is going to be a list style, and this list style is going to have a leading, which is going to be the icon for logging out. So const icon icons.logout. This is going to have a title, const text logout, and we are going to have a on tap functionality, which is going to have a function asynchronous. And inside of the asynchronous function, we are going to say, hey, use that shard preferences, or in other words, create an instance of that shard preference, and let's say await prefs.remove private key. This is going to remove the private key. So now if we reload the application, it's going to go ahead to that create or import page. However, we want also to push directly towards that. So I'm going to just use the navigator and push towards that. So I'm going to say here, push to create or import page using that navigator functionality. Let's save this. And here we have this create or import page stating that is in a class, and this is because we have to import this out. So I'm going to go to the top and import that. So just import packages, pages, create or import.dart. Let's save this. This is going to create that logout button over here. And if everything goes well, if we click here, we're going to go towards that. And if we reload the application, it's going to keep loading this page because the private key was successfully removed. Now let's add the implementation to import the wallet from a seed phrase. So let's click here. This is going to lead us to an empty page, which is going to require the mnemonic phrase. And for that, we have this widget, import wallet. And here we're going to add more functionality. And this page is going to act almost similar as the verified mnemonic page. So let's add that functionality really quick. Again, we have is verified variable and the verification text, also a capabilities to push to the wallet page, which is going to be the one over here. And now here on the widget, let's create a new function. So let's say void verify mnemonic is going to use again the provider and get the private key. Once the private key has been successfully verified, is going to navigate to the wallet page. Now we can just take this verified mnemonic and go back to the import button over here, and on the onPress functionality, just erase this and paste the verified mnemonic. Now I'm going to import the wallet I already have, which has some Sephora balance and some NFTs. So let's paste that over here, allow paste, import, and this is going to lead us here with this wallet address. Now let's code the functionalities to get the assets. It means the balance and also the NFTs. Let's start with the balance. So the Web3 Dart comes with its own function to just get the balances, but we are going to use Moralis for this. And you might be wondering why. Well, this is the Moralis channel, but also is for efficiency. You can see the Moralis APIs are literally the fastest on the market, so getting information out of the blockchain using our APIs is going to also improve the workload or any application you are working with. So we are going to check the balances of this wallet address using Moralis. So for that, if you didn't yet, please go to moralis.io, create your free account, and here on your admin panel, you are going to have direct access to your Moralis API keys. And for that, we are going to use, and for this, we are going to use the endpoint get native balance by wallet. on which we just have to provide our private key, a wallet address, the chain, and if we click on try it, this is going to return us what it found. We are going to be using Python for this, so we can just copy this and add that to our server. For that, I have here a really simple Flask server, which is using Moralis. Remember, you have to install it using pip-install moralis.m to load the Moralis API key into a .env file, and of course the application, which is going to be the Flask server. So in order to get this work properly, we can just go back to the browser, copy all of this for Python, and paste it over here. We don't need the import of Moralis because we already have it, and we don't need the API key because we already have it. The important part is this one. So let's create a new endpoint using this. So I'm going to create a root called get token balance. It's going to have the methods get. This is going to have a function inside of it called def get tokens. I'm going to get the chain as and the address as parameters, and I'm going to set up that on the parameters. So instead of having this burnt address and chain, let's say that I want the address to be equal to the address, and the chain is going to be exactly the same. Now, instead of just printing the result, let's return it. And as easy as that, we have an endpoint to get the native balance of any wallet. So let's save this. Of course, we have to go to the terminal and run this with python app.py. This is going to start our server. And now let's test this out. So here on Postman, I'm going to connect to that server, to the get tokens balance endpoint, and I'm going to send over the chain and the address. The chain is going to be Cephalonia, and the address is going to be, let's say, this one, for example. Let's click on send. This is going to send the request to Moralis, and here we have the balance. This is in terms of weight, of course. So we can use this and get the balances of any wallet, including the one we have on our wallet. So let's go back to the code and use that backend endpoint. So here on the utils folder, I'm going to create a new one called get balances.dart, and it's going to be really easy. First, we need to import the HTTP package from Flutter, and this package we didn't add it yet to the pubspec.yaml, so let's go there and add that HTTP package at the end. So HTTP and the latest version available. So let's save this. This is going to again run that Flutter pub get to install this dependency, so we can return to the getbalances.dart, import this, and create just a new function. This function is going to be, of course, a future. This is going to return a string. This is going to be called get balances. It's going to have as import the string of the address and a string of the chain. It's going to be an async function. And then we are going to say final URL. This is going to be a uri.http. Here we are going to send the URL. So going to be the one of our server, the same we used on Postman. Then we have to declare the endpoint, which is going to be, of course, get balance. And we need to send over the information or the parameters. So I'm going to send over those here. Get token, the address is going to be equal to the address, and the same is going to go for the chain. Now let's create a response. Final response equals to await http.get the URL. Now, if the response status code is 200, it means the response from the server is correct. I'm just going to return the response.body. And if something goes wrong, maybe we make a bad request, let's say else, throw an exception, failed to load data. Let's save this. And as easy as that, we have this function. So now we can return to the wallet page. Let's be sure we import that get balances from the utils. So let's import that. And now we can use that. Where? Here on the load wallet data. So after we get the private key and set that into the shared preferences, after that we are going to say string response equals await get balances address.hex. Which address? Well, the ones we are getting from the private key, of course. we are going to be testing this on the Cephalonia network for this video. Just don't forget to add this inside of the scope of this if statement. I'm going to put this over here. Let's save. Now we are going to have a dynamic data. It's going to be equal to JSON.decode the response we are going to get from the endpoint. Now let's say string new balance is going to be equal to the data. We want to get the balance of it. And if the balance doesn't exist, let's say that we are going to assign this to 0. Now let's create a new ether amount to be shown over here. So I'm going to say new ether amount. The ether amount is going to be called latest balance equals to ether amount dot from big int. This is going to be on way, so ether unit dot way. This needs a big int, so let's say big int dot parse, and the new balance we just get from the endpoint. Now let's say string latest balance in ether is going to be equal to the latest balance dot get value in unit, and the ether unit is going to be ether unit dot ether dot to a string. And finally, we are going to set that balance variable over here with a set state. So set state balance is going to be equal to that latest balance in ether. Let's save this. We can go back then to this balance widget, and instead of 0, just set up here the balance. Let's save. Again, this is not going to be updated yet because we didn't reload the application. And here on the assets tab, I'm going to also put that balance. So Sepholia ETH, and instead of 0, I'm going to again use that balance. Let's save this, and now let's reload the application. If we reload this, now we are going to have the balance of this wallet, which is 0.3 ETH. Nice. Now let's go to get the NFTs of this wallet. This is going to be, again, a really straightforward process. For that, let's go back to the Moralis documentation. Let's go to Web3 Data API, NFT API, NFTs, get NFTs owned by an address. We can check out the endpoint reference down here, get wallet NFTs. Remember not to share this API key with anyone, and same as we did before, we can just copy this code and use it into a new endpoint. So let's do that. Let's go back to our Flag server and create a new route. This route is going to be called get user NFTs with a function get NFTs. In this case, we are going to send over a chain and of course an address. And we are going to paste that from Moralis. So I'm going to take the params, replace this with the address and the chain. We also want the metadata to be normalized in order to access to it. And now we can use that endpoint. Result is going to be equal to EVM API NFT get NFT wallet, sending over the API key and the params. And of course, we need to return that. As this is going to return as more than one element, let's create a response, which is going to transform that response into a coherent JSON file. And now let's say return response. Now we have this endpoint ready to be used, so we can return to our wallet. And here on the lib, I'm going to create a new folder called components, and I'm going to put here a new file called getbalances.dart or nftbalances.dart. And I'm going to fill this up really quick just to render a card for each one of those NFTs. So I'm going to be back really quick. And the most important part on this widget that you must know is that, again, we are connecting to that endpoint, setting up the address and the chain, and then use that response to render a card for each one of those. So now we can just use this here on this NFTs tab. So I can go back to the wallet, import that. So let's go up here and import that. NFT balances, and the only thing we need to do over here is to go to the NFTs tab on this tab view, and instead of having a single child scroll view, which is empty over here, let's just say child NFT leads page, and let's send over the address, which is going to be the wallet address we are getting. Remember when we use this load wallet data, and the chain is going to be Cefolia for this wallet. So Cefolia. Let's save this. Let's click again over here. Let's reload the application, and if we go to the NFTs tab, we are going to have all the NFTs this wallet has, and well, it's going to take a little bit in order to render the images for those NFTs with an actual image. So that's great. We have now the way to get the balance, to get the NFTs of this wallet, to log out. Remember, create a new wallet and import the seed phrase. And finally, we are going to add the capabilities to send tokens to another wallet. So again, on the components, I'm going to create a new component over here called send tokens.dart. And here we are going to use that Web3 library in order to execute the function. So first, let's import mat. Let's also import the material package, the HTTP, and the web3.dart. Now let's create a stateless widget we called send token page. And here we are going to say that we need a private key. Here we're going to add some controllers for the styling. And then we need to set up the constructor of this widget, which is going to have the key, of course, and we need to require the private key. Remember, I told you that instead of getting that from the shard preference, because it's going to overload over and over again the application, we just use that shard preference once we load this widget, and then we are going to send that information as parameter when we render this. Now let's override that build component in order to have a widget with two input fields, one for the amount and one from the address. So at the end, we are going to have something like this, on which we are going to have those input fields. And let me show them here on the actual application. So on the wallet tab, if we click on the send button, which for now has a non-pressed capability which doesn't do anything, let's add that navigation here. So let's push towards that widget. Of course, we need to import that. So let's copy this name and import it over here. Let's save this. So in theory, if we click on send, we're going to have this new widget, which have these two empty input spaces. And let's add the functionalities to them, shall we? Let's go back to the send tokens, and we just need to create one function actually. So let's create that void send transaction. It's going to receive the string of the receiver. It means the account we want to send the information to, the ether amount, which is going to be the transaction value. This is going to be again an async function. We need to have a var for the API URL. This is going to need us to add a RPC client, could be something like Infura or Alchemy or so on. Now we need to have a HTTP client, so var HTTP client equals to http.client. Then we need the it client, so it client is going to be equal to web3 client, sending over that IP URL, that API URL, and the HTTP client, of course. Now we are going to get that private key, so it private key is going to be equal, it private key is going to be credentials equal to it private key dot from hex, and I'm going to send over 0x plus the private key. Remember, this private key comes from that shard preference. Now we need to set up the gas price, so ether amount gas price is going to be equal to await it client dot get gas price. And this is the most important part. We need to add an await it client dot send transaction. This is going to send the credentials, and here we need to declare a new transaction. So transaction, and inside of this transaction, we need to add some information. First, we need, of course, to specify which is the address we want to send to. So to ethereum address dot from hex, and we are going to send the receiver address. We need to specify the gas price, which is going to be the gas price we just declared. Let's also have a mass gas fee over here. Let's also set up a value, which is going to be the transaction value we just declared, of course. And also we need to specify the chain ID. As we are working with Cefolia, the chain ID is 111555111. And with this send transaction, we are going to take the information over here and send the transaction signing with the private key of our wallet. So I'm going to go to the elevated button I have here to send the transaction. And of course, these input parameters are going to come as strings. So I'm just going to transform them in something that the Web3 library understands. I'm going to do it that really quick. And now we can have that function executed. So let's say send transaction. We are going to send over the recipient and of course the ETH amount we want to send. And again, that recipient and the ETH amount are going to come from this input variable. So finally, in order to execute that, in order to be able to send that, we need to connect this with a RPC client. So here, instead of using an empty string, we should actually add some. For that, I'm going to use Alchemy as my provider. I'm going to use, for example, this Cefolia test. Let's click on View Key. Remember, this is sensitive information. Please do not share this with anyone. I'm going to copy mine, go back to my code, and paste it over here. I'm going to save this. I'm going to save this. And once we have this send tokens functionality, we can just try and execute this. So for example, I want to send it to this account and I want to send 0.1, for example. Let's click on send. Let's wait some time, hit on refresh, refresh the application. And as you can see here, we have the new balance, which is 1.0.1999999. And the reason we have this overflow is because we have too much decimals, but we can just solve this really easy by replacing the balance and use something to, for example, a substring over here. And let's just take the first 5 elements, so from 0 to 4. And as easy as that, we have that overflow solved. So that was it for today's blueprint. I really hope you enjoyed this tutorial. You know now how to create a new wallet from scratch on Flutter. You have the capabilities to integrate Web3 into your mobile applications, and now you can use this project as a template in order to create your own wallet with more functionalities. That was it for today's video. I hope you enjoyed it again. Please subscribe to the Moralis channel and I see you on the next occasion. See ya!